Hey guys, today we're going to learn about one of the identities that you can use in trig. There's actually tons of identities. You'll get into it when you take pre-cal next year. We're going real basic today with just one identity. We're going to look at the Pythagorean identity. Just some definitions first. What the heck is an identity? An identity in math is an equation that is true for all possible values. We say this every now and then, like whenever back in like Algebra 1 when you were solving an equation and at the very end you got something like 2 equals 2. We called it an identity because both sides were the same. A trig identity is an equation that involves trig functions that is true for every single value substituted in for the variable. You will find trig identities are especially useful for simplifying trig expressions, and you'll use them a lot for solving trig equations when you get to pre-cal also. Some of the most common trig identities are those involving the Pythagorean theorem, and we're actually only learning one today with the Pythagorean theorem. But there's plenty more you'll get into one day. So when we talked about the unit circle the other day, remember a unit circle has a radius of 1. You can see it right here. We learned that the point on the outside of the circle, the first number is the cosine of the angle, the second number is the sine of the angle. So that point on the outside can be represented by the coordinates cosine of the angle, sine of the angle. Since the legs of a right triangle in the unit circle have the values of sine and cosine in the Pythagorean theorem, so think about your Pythagorean theorem, a squared plus b squared equals c squared. And think about what you would substitute for these values if your legs are cosine of the angle and sine of the angle, and then if your hypotenuse is 1. So the reason this leg is whatever cosine is because that's your x value. The reason this leg is whatever sine is, that's because that's your y value. So if I substitute those values into here, I'm going to show you kind of a weird way to write it first, and then I'll show you the proper way to write it. So in place of a, we can put either the cosine or the sine. I'm going to say sine theta squared. And then in place of the smaller leg, I'm going to put the cosine. Remember, these two can technically be interchanged for the legs. Equals c squared, which for this, since the hypotenuse, the radius is 1, we'll say 1 squared. Okay, so we are building our way into our first trig identity. So the way we actually write this in trig, instead of saying the sine of the angle squared, we actually say sine squared theta, but it means the same thing. And then instead of saying cosine of the angle squared, we would say cosine squared theta equals, and then we just have 1. So this is our first trig identity that we can use to help us figure out different trig ratios. We're going to help us use it first just to prove what the radius of a circle would be. So looking at the question on the bottom, it says triangle ABC is an equilateral triangle. Throwback. Where point A is at the origin, you can see it here, and point C is at 1, 0. Okay, A is at here, C is at 1, 0. What is the measure of BAC? So just going to mark off where BAC is real quick. BAC would be this little angle right here that we're trying to figure out. Now that's kind of an easy angle to figure out because this is a equilateral triangle. In an equilateral triangle, if there's 3 equal sides, there's also 3 equal angles. So 180 divided by those 3 equal angles means each of them are 60 degrees. So that's the first question. What is the measure of angle BAC in both degrees and radians? Well, it is 60 degrees. And then if you remember what that is in radians, oh, I forgot to mention, you probably don't want to have a unit circle handy today for some of our questions, just to refer back to. But if you didn't know, you could also multiply this by pi over 180 to convert it, but you probably also know that it's just pi over 3 because I feel like we've made so many unit circles recently, which is pi over 3 radians. Okay, what are the coordinates of point B then? Well, point B, if we think about our unit circle, would just be the point that's at the end of the 60-degree angle on our unit circle. So I'm going to show you my unit circle. Here we go. here's my 60-degree angle here. Here's the point that's at the end of it. So I'm going to write down this point because this is what it's asking for. 1/2 square root of 3 over 2. What are the coordinates of point B? And notice it says write the coordinates of B using exact values. That means please don't write the decimal. Write 1/2 comma square root of 3 over 2. And then we're going to use the Pythagorean identity that we just wrote down at the top here, that sine squared theta plus cosine squared theta equals 1, to verify that the radius is 1 of this. Okay. So I'm going to do sine squared theta plus cosine squared theta, and we're going to check to see is that equal to 1 according to the formula. 1. There it is. Okay, so when you have a point right here, remember these are certain cosine and sine values of that angle. This one right here would be the cosine of the angle. Square root of 3 over 2 would be the sine of the angle. So I can take these two and plug them in to see if I end up getting 1 for that value on this side. So my sine would be square root of 3 over 2, so root 3 over 2 squared. My cosine is 1/2, so that would be 1/2 squared. And again, we're just checking to see does that equal 1 according to our Pythagorean identity. So remember, to square a fraction, you're going to square the top and square the bottom. So if I square root of 3, I'm just going to get a regular 3. And then if I square 2, I'll get a 4. Okay, on this one, if I square 1, still get a 1. If I square the 2, I'll get a 4. Again, just checking, is this going to equal 1? 3/4 plus 1/4, it sure does. That's 4/4. And 4/4 is 1. We have officially verified that the radius is 1 using our Pythagorean identity. All right, keep that unit circle handy. We're going to need it for the next questions. Okay, let's see what we've got here. It says the angle theta is located in quadrant 4. That's in, what is it called? Roman numerals. And the sine of theta is negative 13 over 85. So we have some important information here. Angle is in quadrant 4. The sine of the angle is negative 13 over 85. And we're trying to find what the cosine would be. Okay. So there's lots of ways you can do this. But since we now know that we have the Pythagorean identity, we can use the Pythagorean identity to help us. I'm going to rewrite it on this side so I don't have to keep flipping back and forth. Again, it is sine squared theta plus cosine squared theta equals 1. Okay, so I'm going to start by just setting up what I have. Okay, I know there's a 1 here because that's in the formula. I can take my sine value and substitute it here. So we'll have in place of sine squared theta negative 13 over 85 squared, because this is my sine of theta, plus cosine squared theta equals 1. And we can work on basically trying to solve this for cosine. Okay. First thing I'm going to do is just square this fraction. Remember, when you square a fraction, you're going to square the top, square the bottom. If you square the top, negative 13 times negative 13 is 169. And if you square the bottom, oh yeah, you might need a calculator today. If you square 85, you get 7,225. Big number. Just writing the rest of it. Okay. And then from here, again, we're trying to solve for the cosine. Okay, so I'm going to subtract this ugly fraction here. Subtract 169 over 7,225. Okay. Now, I don't think you need an actual calculator to solve this right here. I mean, if you think about it, you can take this 1 and just rewrite it as like 7,225 over 7,225. But if you need a calculator, you're welcome to calculate it. So I'll be left with, where do I want to write this? Let me move it over here. Okay, so I'll be left with cosine squared theta. And then if you do this turned into 7,225 over 7,225, and then subtract 169 over 7,225, you get 7,056 over 7,225. Where did I put my calculator? Ah, there we go. Okay, now to cancel a square on this, it's basically just like if you had x squared and you were trying to cancel the squared on x squared, you're just going to take the square root, which means you'll also take the square root over here. So the square root of cosine squared theta just becomes cosine, which is what we were solving for. On the right-hand side, taking a square root of that ugly fraction, that just means you need to square root the top. 7056, that's 84. And then square root the bottom, 7225, 84 over 85. That is not a pretty answer. But remember when you're doing a square root and you're solving, technically this should be plus or minus, okay? But only one of those can be the right answer, okay? It's not both positive and negative, 84 over 85. So we have to use this information right here where we were told the angle is located in quadrant 4 to help us figure out whether we should keep the positive or whether we should keep the negative. And here's where your unit circle is going to come in handy. So what we're looking for on the unit circle is in quadrant 4, which would be this one down here, is the cosine positive or is the cosine negative? So remember, the cosine is simply just the x value of the point, and if you look down here, all the cosines are positive in this quadrant. So if we are trying to find the angle that is in this quadrant, like we were asked, if we were trying to find the angle that's in this quadrant, it's going to need to be a positive cosine. I'm going to write down that cosine is positive in quadrant 4. So that means that we don't want to keep the positive and negative, we just want to keep the positive, and we're going to throw away the negative. So our final answer, cosine of the angle is positive 84 over 85. Okay. I'm going to make us a little diagram over here just so we don't have to keep flipping back to our unit circle. We can just kind of refer to this. Okay, so remember in quadrant 1 you're going to have a positive and a positive, okay, because you have to go right and up to get to these points. In quadrant 2 you would have a negative and then a positive because you have to go left and up to get to these points. In quadrant 3 you're going to have two negatives because you have to go left and down to get to these points. I'm talking about like points on a unit circle. And then in quadrant 4 these would be positive and negative because you have to go right and down to get to these. Okay. And then also, if you remember on top of that, that each of these just represents a cosine and a sine value. Cosine, sine, cosine, sine. So this should help us remember where they're positive and where they are negative. Okay, next question. It says the angle theta is located in quadrant 3. And the cosine is negative 13 over 50. What is the exact value of sine? Okay. All right, so we can start one of two ways. We can start by looking up like whether sine should be positive or negative. We can start by just immediately trying to solve for sine using our Pythagorean identity. I think that's what I'm going to do. So at the beginning, I'm going to have my sine squared theta. I don't know sine yet. Plus, and then I'll have my cosine squared theta, which really just means square your cosine, equals 1. And then I'm going to start working on simplifying and solving this for the sine value. So first thing I'm going to do is square this little fraction here. If you square negative 13 and square 30, let's see what you would get. Square 13, that's 169 over, this would be 900 if you square it, equals 1. And then from there, I'm going to subtract it off of this side so we can isolate the sine. Minus 169 over 900. Okay. That's going to, oh, I forgot my square on here. That's going to leave me with sine squared theta equals, this would be like basically, you could rewrite it with a common denominator by saying 900 over 900 minus 169 over 900. Or, I mean, you could also just use your calculator. You end up getting 731 over 900 when you subtract these. The ugliest fraction ever. 731 over 900. And then last thing we have to do is isolate just sine, because right now we have sine squared. So we're going to take the square root. Take the square root. I don't think 731 divides by anything. Let's see. Second. 731. What does it divide by? I'm just going to make a table in my calculator just to kind of check to see. Yeah, I don't think. Oh, it only divides by 17 and 43, and both of those are prime. So this square root is not going to be able to simplify on the top. We can simplify the bottom though. So square root of the left would leave us with just sine of theta. Square root of the top we're not going to be able to simplify because it's only 17 and 43, and both those are prime numbers. And on the bottom, square root of 900 would be 30. Okay. Now remember, when you take a square root, you're technically saying, okay, it could be positive or negative. So we have to figure out, do we keep the positive or do we keep the negative? And that's going to be based on where is the sign value, or what is the sign value in quadrant 3? Is the sign positive or is the sign negative in quadrant 3? So quadrant 1, 2, 3, the sign value is negative there. So of this answer, we're going to want to keep the negative part of it. I'm going to make myself a little note here. Sign is negative in quadrant 3. Got it. Okay, and then I'll write my final answer, just keeping the one negative. Sine of theta equals square root, or negative square root of 731 over 30. That is not a pretty answer. All right, next up, find the exact value of cosine. Sorry, I was trying to lift up my camera. If the sine is negative 1/3 and the tangent is greater than 0. Okay, so this one's asking us slightly different, but it is giving us similar information, just worded different. So we're trying to find the value of cosine if we know the sine and we also know the tangent is greater than 0. So this part where it says the tangent is greater than 0, that's going to help us narrow down which quadrant we should be looking in. So if we can figure out where the tangent is greater than 0, then we can figure out whether the sine would be positive or negative. But let's first start by just solving for sine, or solving for cosine. Okay, so I have my sine squared theta plus cosine squared theta equals 1. So here's my sine. So I'm going to have negative 1/3 squared plus, we don't know cosine, we're solving for it, cosine squared theta equals 1. Squaring negative 1/3 is not too hard. You just square 1, you square 3, you get 1/9 plus cosine squared theta equals 1. From there, if you subtract 1/9 from both sides, yay, finally a mental math one. 1 minus 1/9 is 8/9. Cosine squared theta equals 8/9. From there, we can take the square root of both sides to cancel the square on the cosine. We'll take the square root over here as well, which simplifies just a little bit. So on the left side, we'll obviously just get cosine of theta. On the right side, we'll have square root of 8 over square root of 9 would be just 3. And then square root of 8 does actually simplify, because in square root of 8 you have a 4 that is a factor, and the square root of 4 can come out as a 2. So you would have in here 4 times 2, which means square root of 4 will come out as 2, and 2 will stay. So my final answer would be, or not final answer yet, where you still got to figure out, is it positive or negative? 2 square root of 2 over 3. Okay, up next, to figure out whether we should keep the positive or negative, we're going to start by using the fact that we know the tangent is positive. Okay, so again, you can look at your unit circle if you want to, but we kind of wrote down the gist of it over here. The tangent is the sine divided by the cosine. This divided by this, this divided by this, this divided by this, this divided by this. Okay, so there's only 2 places where the tangent is greater than 0, meaning tangent is a positive number. If I did a positive divided by a negative, my tangent would be negative here. If I did a positive divided by a positive, tangent is going to be positive here. So it is positive in quadrant 1. It's also positive in here in this quadrant 3, because if you did a negative divided by a negative, you would get a positive. Okay, so I'm going to make myself a little note here. The tangent is greater than 0 in both quadrant 1 and 3. Okay, so you're probably saying like, well, how the heck do we know whether it's in 1 or 3 then? Okay, so in 1 or 3, obviously you have a cosine that's positive here, a cosine that's negative here. We got to figure out which one it is. That still didn't help narrow it down. The second thing that's going to help narrow it down is the fact that the original sine value was negative. If the original sine value was negative, you'll see that only happens in quadrant 3. It does not happen in quadrant 1. So if the original sine value is negative, that means the cosine is going to be negative. So I'm going to say sine of theta is negative in quadrant 3. So this angle is officially in quadrant 3, which means the cosine will be negative. This one was tricky. Cosine of theta equals negative 2 square root of 2 over 3. Pen is smudgy. Okay, let's see what we got next. Sine theta is 1/2 and theta is in quadrant 1. Find tangent of theta. Okay, so notice they don't give us, it's not asking us to find the cosine, but we're going to need to find the cosine because if you remember way back, we learned that the tangent of theta is the y value divided by the x value, which is actually just the sine divided by the cosine. So if we need to find the tangent of theta, we have to find the cosine of theta because we got to be able to divide the two. So I'm going to start by doing my Pythagorean identity and doing my sine squared plus cosine squared equals 1. I'm going to solve this for cosine. If you square 1/2, you get 1/4 plus cosine squared theta equals 1. If you subtract a 4th on both sides, I don't need to show that. I think we got that. 1 minus a 4th would be 3/4. Okay. We'll take a square root. Okay. That would give me cosine of theta equals, this would simplify to square root of 3 over 2. But we got to decide, is it positive or negative? Positive or negative, because we always have that possibility of when you take a square, it could be positive or negative. So we're going to go look. In quadrant 1, is the cosine positive or negative? We have it written down on the side here. In quadrant 1, the cosine is positive. I said we're only going to keep the positive answer. Okay, so cosine of the angle equals square root of 3 over 2. Okay, so now that we know the cosine, we can finally answer the actual question. The question is find the tangent. So to find the tangent, I'm going to do my sine, which was given to me here, divided my cosine, which I just found here. So tangent of the angle equals 1/2 divided by square root of 3 over 2. To divide fractions, you do a little keep change flip, multiply by the reciprocal. Okay, so that's my tangent. Okay. I do have a couple of numbers diagonal that I can cancel. So I would get 1 over square root of 3. And then you could still rationalize this. Multiply by root 3 times over root 3. All right, I think we made it. Final answer. Tangent of theta equals 1 times square root of 3, which is just root 3. And then root 3 times root 3 is 3. Ta-da. All right, next up, practice AP question. Which of the following equations is true for pi over 2 is less than theta, which is less than pi? So if you look at all these answer choices, they're all some version of this Pythagorean identity, but solved for cosine. Okay? So notice they're all solved for cosine. Now, other things I notice about the answer is 2 of them are negative, 2 of them are positive. So I'm going to highlight that just so I pay attention to that. So I'm going to start with just my normal formula for my Pythagorean identity formula. Here's my little sine squared theta plus cosine squared theta equals 1. Okay, that's how we're going to start. Now what I'm trying to do is I'm trying to isolate cosine. Okay, so on here to isolate cosine, you can do it without numbers the same way we did it with numbers. We're going to start by subtracting sine squared theta. That gives you cosine squared theta equals 1 minus sine squared theta. Okay, to cancel the square on it, you're going to take a square root. You'll take a square root. And you'll get cosine of theta equals, we don't know yet, positive or negative, 1 minus sine squared theta. Okay, we do have that answer on 2 of them. Both C and D have 1 minus sine squared theta, 1 minus sine squared theta. So we at least know it's not A, it's not B. Those had plus signs. So to figure out whether we keep the positive or negative, it's going to come back to this right here. This is a very fancy way of telling you what quadrant it's in. It says the angle has to be between pi and pi over 2. So if you look at your unit circle, here's pi, or here's pi over 2, here's pi. So this would be quadrant 2. So in quadrant 2, the cosine is negative. Remember, cosine is the x value. So we only want to keep the negative because cosine is negative in quadrant 2. Which means it's D. And I'm just going to write down what my brain thought about there. This is quadrant 2. Cosine is negative in quadrant 2. All right, guys, I hope y'all learned something today.